First lesson is interval notation. The reason I'm doing this is in the back of your book. If there are odd problems that I assign, sometimes the answers are in interval notation. This is what interval notation looks like. And this is not the point A comma B. What that means is this is the interval from A to B. So the interval from A to B does not include A, less than, does not include B, just a less than. And there's a graphical representation. And another way you can graphically represent it too, you could do that also. Both are correct. And if you classify it, it is finite and open. Or you could have something like that with the squared off brackets. And that means it includes A and B. And here's the graphical representation. It includes A and B. Or you could graph it like this. Okay, the points A and B. Either one's correct. And this is finite and it's closed. Here's the interval from A to B. It includes A, does not include B. And anytime you need to pause it to write them down, pause it, because I'm going to go through these very quickly. Here's including B. These are also, all these are finite. These two are half open. That's negative infinity to B. It goes all the way to the left. And the reason it's always rounded with infinity or negative infinity is because you can never reach infinity or negative infinity. Because you keep going and going and you never get there. So it's everything from B down. So smaller number, larger number. Always the smaller numbers first, larger number second. And this is infinite and it's closed. Here's infinite and open. Does not include B. Includes A, so A is your smaller number, positive infinity is your larger number, so anything greater than or equal to A. And this is infinite and closed. Here's infinite and open. And the very last one that I have here is negative infinity to positive infinity. So this is all real numbers. X such that X is contained in the real numbers. This is contained in, I usually write it when I write it, real numbers like that. Okay? Usually in books, it's a little bold, it might be a little script. But if you're going to write it, you can write it like that. That's all real numbers, so everything on the number line. And that's infinite, and it's classified as open and closed. So what I'm going to have you do is you might have a graph, and you have to write in interval notation what it is, or you have interval notation, and you might have to graph it. You might have to write it in set notation, the set of X such that A is less than X is less than B. Or something like this, X such that X is greater than A. Union and intersection is the next thing I want to talk about. If A and B are sets, so we have two sets. We have a set A and we have a set B. There's A, that's B. The union, and it's denoted as something that looks like a U, are the members that belong to A. So it belongs to A, or it belongs to B, or it belongs to both of them. So it's everything combined. So that's union. Intersection, if this is A and this is B, it's only the members that belong to both A and B. So where it overlaps. So it's only where it overlaps. It has to belong to A and also to B. So let's try to find the intersection of this, simplify those. And I could have also written this as a left parenthesis 0, 5, like I have down here, union 1 comma 7. It's the same thing down here. So union, it's ones that belong to A or B or both of them. What I like to do is I like to graph it. So if I were going to graph it, 0 to 5, 1 to 7. And there's what the graph looks like. Here's 0 to 5, here's 1 to 7. So if I take both those graphs and put them together, the result will be from 0 to 7. So that's what it looks like. So now you can write x such that 0 is less than x is less than 7. Or if you're going to write an interval notation, it would be a left parenthesis, 0 comma 7. The next one, intersection. X is less than 1, so there's 1, there's less than. X is greater than or equal to 0. 0 falls here, and it's greater than or equal to, so it includes 0. And it goes that way. So if I take those two graphs and combine them, only where they overlap is your answer. So they overlap at 0, because 0 is included in both of those. But they don't overlap at 1, because 1's only included in that one, and not that one. So here's what your picture would look like if you had to graph it. So that would be the set of all x such that 0 is less than or equal to x is less than 1. Or the bracket 0 comma 1 with a rounded parenthesis after it. Last one here. X is less than 0. So there's 0. There's x is less than 0. There's 0. X is greater than 0. So put them together and where they overlap. And I hope you see that they overlap nowhere. Nothing. Because they both don't include 0. So they do not overlap. So this is the empty set. So you will have the worksheet to do. So do the worksheet for this evening and bring it to class tomorrow.